Hi y'all! Today we are continuing with the derivatives portion of our Calculus 1 series. We'll be talking about related rates. So I'm just going to be doing an example so that we can talk about the steps that go into these sorts of problems. So here's what we're given. Air is pumped into a spherical balloon so that its volume increases at a rate of 100 centimeters cubed per second. How fast is the radius of the balloon increasing when the radius is 25 centimeters? So our first step is always to turn what we're given into actual formulas and equations. So that instead of just a word problem, we have something we can actually do math with. So basically, the fact that air is pumped in so that the volume increases at this rate of 100 centimeters cubed per second means that dV dt, right, which is the rate of change of the volume of the balloon with respect to time, is going to be 100 centimeters cubed per second. Now, we have a formula for the volume of a sphere, right? The volume of a sphere is going to be 4/3 pi r cubed. So that's going to be very important. What we're trying to find here is dr dt, right? And we're trying to find it specifically when the radius is 25 centimeters. So basically, our first step here is to move from this formula into an actual formula for dV dt in terms of the radius. Okay, so what we're going to do is we are going to take this formula and we are going to apply ddt to both sides. So from there, we find that dV dt, so we're going to bring down the 3 from the r cubed, and that's going to cancel out with this 3. So we just get 4 pi r squared, and then we have to do chain rule, right? This is in terms of time, not in terms of the radius. So we have to multiply by dr dt. And we know that this is equal to 100, right? So now we can use this to solve for dr dt. So dr dt is going to be 100 divided by 4 pi r squared. We can divide 100 by 4 to get that this is 25 over pi r squared. Now, we specifically want to find this when the radius is 25 centimeters. So, at r equals 25, to find dr dt, we just plug in 25 for r. And so one of these 25s will cancel with this 25, and what we end up with is 1 over 25 pi, and that is going to be in centimeters squared per second because our volume was changing at a rate of centimeters cubed per second, and radius is a two-dimensional quantity. So anyway, this is just a basic introduction to how related rates problems work. Again, first step is always to identify what we can take from the problem and turn it into equations, and then we are going to manipulate whatever formula we find relevant in order to solve for the rate we're trying to find. If you enjoyed this video, please like and subscribe, and I'll see y'all next time.